Hello.
You're welcome. Thank you.
Okay, here we are. Take the echo away. So, okay.
Yeah,
Now
so
I'm here.
should we start or maybe we wait for 5 minutes for more people to join?
We wait 5 minutes actually, so that everybody has a chance to come in there. Hello, everybody already, those who are already joined.
Yeah, so I think we can wait just 5 minutes, then we'll start immediately.
Mm-hmm. I think everybody got the same link for login, or maybe if it's anybody struggling. I put the link in there.
Yeah, for everyone who registered, then got the link.
Yeah.
That's quite okay.
Yeah. Okay, I think our 5 minutes are over, so let's just start there. Anybody joining later, I think they will still keeping up. Hello, everybody. So I will talk about today about something which is called cognitive industries. You will hear this expression cognitive quite soon because we believe that is the next breakthrough in artificial intelligence. So before you heard about smart cities, smart industries, everything smart, and now we are going to the next level, which is cognitive. Cognitive means you giving artificial intelligence and adding it to everything which is smart before. So what I will going to tell you now is give you a small description about what a cognitive factory is, to give you an imagination. Cognitive industry is, and in the end, since we are here still speaking about Africa and the possibilities in Africa, I will also try to bring this a little bit in relation, how useful it could be in Africa, or when it could be useful, or what maybe is needed to make it useful in Africa. So for the cognitive industries, I'm going to share now my presentation so that you have a little bit of a backdrop. So up. So it is coming. And yes, so here it's there. So artificial intelligence plus industries 4.0, that is what we then call cognitive industries or cognitive factory. That's there. And you remember a little bit smart industries, you might have heard, smart cities you have heard. So for the definition there, a smart city is that you have electronic devices everywhere where it's important, that you can monitor a city, a house, a factory from a remote place. That is what the idea of a smart city, of a smart factory is. And now we need to take this digital twin that we create. A digital twin is simply having all the data from the real world somewhere on your computer so that you can see everything that happens in the real world, also in the digital twin on the computer. And now you can go into this digital twin. We make changes in the digital twin, and then the digital twin needs to go back to the real world, to the what we call physical assets. So things that are in the real world, and make the changes in the real world. An example for you is relatively easy. You have a door. So the door can be open or closed, or it can be half open. So a smart factory would have a sensor, would sense whether the door is open, whether the door is closed, and whether the door is half open. And now we would have also the possibilities to remotely control. So they say, okay, this door should be open, this door should be closed. And then we have a little motor, or in this case, a robot that closes the door, or that opens the door, or keeps the door half open. So you can remotely control the door. If you expand this idea, if you want to see a cognitive factory in the real world, if everybody has heard about the autonomous driving cars that drive themselves, a self-driving car is a cognitive factory, because there is a computer. The computer takes information from cameras, from sensors, to know how the traffic is going. Then the computer decides how the car should behave. So a self-driving car is already a cognitive factory. So that would be a very extreme, but the simple case would be simply controlling a door. You also hear a lot recently about agentic AI, artificial intelligence agents. So intelligence agents that are able to control something in the real world. Well, basically, this little robot, or in the case of the door, this little motor only, that is an agent. And if this agent has artificial intelligence built in there, can make decisions by themselves, then we have an AI agent. Also take the example of the door. The AI agent is not told how to close the door. The AI agent is told, close the door. How to close the door, and to check whether the door is really closed in the end, that is done by the agent. So we do not control the closing of the door. We only tell the agent, please close the door. And that's the same like you would do in the real world as well. You maybe have a doorman, somebody, or a janitor. You tell the janitor to go down the stairs and please close and lock the door. So the same thing we can do now with an agent, and an agent with AI built in. That is nothing else what you have known for a long time as a robot. To summarize cognitive factories, so cognitive factories are smart factories that are in the end self-monitoring. And when they self-monitor, they can learn. So they are self-learning. When they have learned and monitor, they can optimize themselves. And if something breaks or something is malfunctioning, then they can repair themselves. Also in a factory, maybe some light bulb, the light is flickering. So the smart factory would find out, okay, the lamp is flickering, we have to replace the lamp. So the AI can make a decision, okay, if the lamp is flickering, just repair it. So he tells a small agent that might be a drone. So the drone is flying up to the ceiling, takes the lamp out, and puts a new lamp in there, and everything is repaired. You do not need humans to make such decisions. These decisions are relatively simple, they are safe, and they can do this kind of repairing themselves. And in the long run, it would be also doing like this. You would not even tell such an AI to repair how repairing goes. If the AI has seen some humans replacing the light bulb, then the next time he might have learned from the human how the replacement takes place, and it can do the replacement on its own. So that is something, the vision we have in the near future. And if you've seen what wonders we have done with the generative AI in the recent years, you can imagine that these things will be possible and will happen quite soon. What we need for a cognitive factory is, of course, we need sensors everywhere. Like in the self-driving car, you have so many sensors. You have to do a sensor to know how, if the door is open or closed, or if the door is only partly open. But you also need sensors that control other sensors. And of course, you need actuators. Actuators is something that makes a manipulation in the physical asset, in the real world, the robotic agent, and it is should be accessible from anywhere in the internet. That is one of the important elements of the cognitive factory. So if I'm sitting here, so I'm calling you now from Germany. So if your factory is Tanzania, if everything is in a digital twin, I can do the control here remotely. Or if you fly to the moon or to the Mars, you can control your pod, your landing mission directly via a remote action. What we need, or what we will have transparency of information, because we will have information about the whole factory. If you go in a modern factory today, you still will find that a lot of information is not known. You have to go to the floor, you have to go look directly in the machine if something is blocking or not. So if you have sensors everywhere, all the information will be transparent, like in a self-driving car. Self-driving car, you cannot afford to have a single movable component not to be monitored by a sensor. In the end, that is what we do. We will have a computer assisted design and computer assisted decision making and learning. And with the agentic AI, we will have decentralized and autonomous decision making. So that is how a cognitive factory in the future will look like. If you see occasionally here the name Karuna X, Karuna X is the name for our project. So the project for a cognitive cyber factory, where we build it. So what we have a bus system, a communication layer, like you have in every modern machine. That is where all the communication goes through. We have security layers, and we communicate with the physical asset. So let me have, here's the point. That's a laser pointer. So we have the physical asset goes through a security layer and communicates with the bus layer. That does the communication. And then we will have data lakes, we will have analytics engines, we will have simulators, and we have a cockpit to allow seeing what happens really. So here you see our control station, that is our cockpit. The cockpit looks onto the digital twin to show what in the real world happens. And the data lake is also already a very complex agent. It's not just a data storage. A data lake is permanently cleaning the data, looking for data that is outdated, because otherwise your data lake is growing, and then you will not be able to find anything. If data is taken from the data lake regularly, you might have the result aggregated. So the next time somebody's asking the same question, you just give him the same answer and not always aggregate the data from the scratch. You can classify the data, you verify. So you see a data lake is already an agent that does analytics. We have the classical model, we have descriptive, that is the one with the bar charts, with the pie charts that you had traditionally. Diagnostics is that an artificial intelligence or a machine learning component is already taking the data and finds patterns if something is good or bad. Predictive is making time series prognosis, what happens in the future from what they have learned. You make a prediction. So this machine is charting jittering now. So if you will run this machine for another 10 days, it will probably break. So this is a prediction. And if you have made a prediction, you can look in a book that gives you standard operation procedures that tells you if the machine is probably about to break, what shall we do in the end to get this all problem solved. But a good thing with the digital twin is the simulation. If you have, with cars, traditionally, you have crash tests, you have crash test dummies. So you have to destroy your car. But with a digital twin, you can do a lot of testing without destroying anything in the physical world. You simulate the destruction, you simulate a problem. If you think of a flight simulator, pilots nowadays, they learn in a flight simulator what happens if all the engines get stalled. So if all engines are stalled, what should they do? They learn it in a flight simulator. They don't have to go into a real airplane to simulate this critical condition. They do it in a simulator. So
you're lost, Mr. Axel. I don't understand. Network issues or what? Cannot hear you.
augmented reality addings in there. And now we come to the most interesting part, because everything is about artificial intelligence, and the artificial intelligence, these are pluggable components. You can plug in OpenAI, you can plug in Google TensorFlow, you can plug in Mistral, Anthropic engines, whatever you can have. There is so many engines out there. You choose the engine you want, you plug it in there, and then you can do the machine learning. You can do generative AI to produce already results. You can do pattern recognition, and in the end, you build agents that are moving forward. So the summary of this is, from smart to cognitive. Smart industries are observative. They observe what happens, and cognitive is proactive. A cognitive has intelligence built in. It does a lot of actions automatically, and it learns also what to do. Use cases of cognitive is in design, in training, in projects, management, in production, procurement, very important thing, supply chain. You check if your supply chain is stable. So if maybe some components are delayed because of the Strait of Hormuz is blocked, then you try to rearrange your production side and use the components that you have and optimize so that your factory is not going to a standstill. That can all be done automatically with an intelligent process of the artificial intelligence of a cognitive factory. Also, if you have built a car, even a self-driving car is not standalone. All data that is in a self-driving car is now mirrored to the owner of the self-driving car. So Tesla can monitor the data of any car that is driving around. from a central place, so they can monitor the operation. Of course, the AI will look for safety and security. It will do predictive maintenance, and it will make suggestions how to improve the whole process when it finds that certain errors and malfunctions happen relatively often. A question that I get also there is actually, now I speak about factories, manufacturing. Of course, this is one of the big cases, but the model of a cognitive factory you can use basically everywhere. You can use it in education. You use it in the shopping center. You can optimize your complete shopping center. You can do it in logistics. There it's already widely used. Optimize the transportation. You can use it in public safety by monitoring public squares, public spots, and see that everything goes in order. Energy grids are using this already very intensively, so that there are no energy failures happening out of a surprise. So they try to predict if there is a big load coming and try to balance the load there. Government is using it. They're using it for security. So you all have heard probably about companies like Palantir. So they are doing actually the same concept, the same principle, but they use it for security screenings or scrutinies there. Finance will look for finance fraud, for tax frauds. Airports are using it intensively to get the land side and the air side operations done properly. And if we move here to entertainment and recreation, well, entertainment, all the game industry, they are the front runners in this one. They experiment a lot of things, and the good ideas will then come into the cognitive factory. And recreation, well, you can have a completely AI-driven fun park. Disneyland, a cognitive Disneyland, you might have had. So we have a lot of projects running there, but actually I don't want to exaggerate. Actually, this is all somehow in experimental phase in the smaller size. If you're a company like Toyota, if you're BMW, if you're a Siemens, your factories are already doing everything like this. But these things are now coming to the small mid-sized businesses, and we can have cognitive factories. We have one running for the fuel cells building. But also a very interesting thing is the sports intelligence hub. We can use this model in sports. We can monitor stadiums for security, but we can also use this model to monitor the game itself, to find out if a player is performing well or might getting tired in the middle of the game. You make some kind of prediction there. So this is just the examples that I already mentioned, or in the stadium. So we can use it in talent scouting and security monitoring, media management. We can control the crowds, that there is no accidents happening. So if you have to clean one rank, the AI can already give orders to orderly and properly leave the stadium. And something that is coming very much now, actually, virtual live gaming. So while you see a real game, you take the game and put it into a computer game, and in the end, you can continue the play, maybe from football minute 60, and then play it the way how you would like it. Those who are playing chess, they know this. You take a famous chess play in the final state, and then you try to change the moves and see what would have happened if something has gone differently there. So there is a lot of examples here, and we use it in talent scouting, we player profiling, and we take biometrics. So that's all things that already exist in a small way, and every year and every month things are growing and getting more widely used. So, okay, that is not for you. That was actually what I wanted to say about the cognitive factories for the moment. I don't, and before I finish, I promised you that I also wanted to say, since we are doing this now for Africa, the area where you, in the end, would benefit most from cognitive factory is definitely in agriculture. Optimizing your agriculture scenes, optimize the supply chain, making sure that if you grow crops, that the crops are going in the right time, in the right moment to the markets where you can sell it for the best prices. But you can also use it to find out if certain pests are coming, to find out immediately a solution, maybe even an automated solution to avoid that this pest is there. And if you are fighting pests in agriculture, does not mean necessarily using poison. It can also do done in a mechanical way. So if you have small miniature robots, these robots can maybe go and just dig in the soil to avoid that a certain pest is growing, or it's looking up in the internet a solution and say, okay, if you have too many snails in your garden, then you just bring in some ducks and the ducks will eat the snails. So you can use the power of artificial intelligence to find solutions in real time. And a lot of these actions can be done also in real time by some small robots. So that is the promise. Now the backside is there. People would say, okay, if ever there is a robot, what do I do with the people? Well, say you will need a lot of people, diligent people, to build all this. If I say you have a small robot, somebody needs to build the robot. And currently, you can be sure there is not a robot who is building an individual robot. You can build a robot which you have 1,000, 10,000 times according to template. But most robots you will need in agriculture are individually designed ones. So you need engineers, electricians, you need mechatronics people, and you need people who understand farming while they have a good understanding of engineering. So, point is there. If you take the vision of a cognitive agriculture, then you will create jobs in agriculture for people who have an engineering mind. It's the same thing that happened in the beginning. The people were using the hands to dig holes, then they got a shovel. So since then they're using shovels, but now you have tractors, and if you have a tractor, you don't want to use your shovel anymore. And the same way, if you would have the cognitive one, you will use the cognitive agriculture to do a better agriculture. But that does not mean that there is not work for the people. As in the end, there will be even more work for the people. So I try to answer one question preemptively, because that's a question that comes always the time, what happens with the people? The people will be good in a job. Okay, thank you very much for the moment. I think I can stop it here. So if you have questions, but I give it back actually to Dennis. He can tell what we're going to in the next moment. Thank you.
Thank you. Thank you very much, Mr. Axel, for your informative, for your very nice presentation. So before I allow questions from the audience, I would like to first ask you a question that I'll need you to respond, and then thereafter I will allow the audience also to ask their questions.
Yes.
The audience, maybe you may raise your hand, or you can just post your question in the chat, and then we'll be able to channel them to the speaker. So my question is, what would you say is the most critical step for countries, particularly in Africa, to transition from the industry 4.0 into cognitive industries that we're speaking about? Thank you.
Okay, the answer is relatively easy because the most critical element is infrastructure. You need a good and stable internet. In order to have a good and stable internet, you have to get good and stable energy. You know, artificial intelligence is using a lot of energy. So if you want to really use it in the same way as it is done in the industry nations, you will first have to set up a big infrastructure in there. But on the other side, building the right infrastructure is a duty, is a task, but that is something you need to start in any case. So that's whether you want cognitive or not cognitive.
Thank you. Thank you for such a response. Now, I'd like to take this time to welcome the audience. Now, if you have any question, please, you can just raise up your hand and then I will allow you to proceed. You're welcome.
While you think about your questions, let me just add one thing to the previous answer, which I gave actually. I forgot actually to say what is required to build a good infrastructure. Required is good education of people. You have to make good, well, let's say mechanics, good electrical engineers, and people who are willing to work on the ground. So don't forget education. I just wanted to add this. So please now get me your question. Somebody has a question put in the chat?
No, there is no question on the chat. I just posted a message.
Okay.
We'll be interested to join our next session, which we call it an AI for Leaders Breakfast Forum. This is actually a monthly event. Actually every morning between 7 to 9 a.m. So it's a monthly networking event whereby you also discuss these robotics, AI topics, inviting different keynote speakers for the same. So for whoever is interested, because we have, it's a hybrid session whereby we have the physical, but also an online session as well. So for those who are going to subscribe, then we'll directly share the link for them to be able to access the session. So if there is any question, please, and maybe while we are waiting for questions to come, as you can see, I don't know if the topic is difficult in a sense that we do not have questions, or maybe we have understood. But I can see there is a question from Yahya Ibrahim.
Yeah.
Asking what could be the risk for a PhD student.
Well, for PhD students, I think there is a lot of research potentials, because if you already are able to work with artificial intelligence frameworks, maybe with Mistral, OpenAI, or TensorFlow, or any of these things, we are in the beginning of this, let's say, next breakthrough. So we need especially to learn also how we can make this transition from a digital twin back to an agentic AI to do real physical things. If I tell you that you're using open a door and can control the door from remotely, this is not so easy. So what we need is concepts how we can safely allow doing actions done by an agent. Safely is the important thing. Think of the self-driving car. So if the self-driving car makes a decision to turn left, then it needs to be sure that if it turns left, that it's not hitting a wall or hitting another car. So research is widely. So let's take the part with the agriculture. Especially, I would like to push in Africa, always to go in the agriculture side. To see what kind of little robots, agentic robots, are needed to help a farmer really. And this means actually going down to the farmer, speak with the farmers, find out what the farmers really need. Don't come with a drone. Don't come with some fancy app. That is not what a farmer needs. A farmer needs a solution to get his pests away, or find out actually how he can save on fertilizer, on chemical fertilizers. So, but that is, if an AI can help the farmer to reduce fertilizer, to reduce pesticide, if it can help him to take the harvest out on the Monday instead of a Friday, because on the Monday he can get a better price on the market. These are AI solutions that a farmer would really need. But to know what the farmer needs, you have to go to the farmer, speak with them, and then take your mind and how to translate it into AI.
Thank you. I think you have responded correctly. And there is another question from Samada. Could you please give some idea on the costs from the customer or user perspective to buy, implement, and operate with such solution of cognitive digital factories? And it's talking about from the initial cost and recurring costs in a broad range.
Okay. It's not so easy actually to give a ballpark number. We calculate typically 20% of the setup cost of a factory. So if your factory costs $1 million, you will have to have $200,000 to add the capability of a cognitive factory. So we say actually, depending on the value of a factory, take 20% of it, and that is, let's say, the cost that you should put in your books for making the transformation. Of course, if you're a small factory, if you're a small site, the costs will be relatively higher to the whole cost. If you're already a big factory, a 100 million factory, then the costs will be relatively lower to the whole cost. But 20% to the value of your factory, that is what I would put in the books.
Good. Thank you. We have another question from Jess. Oh, anyway, he was just introducing himself.
He was just greeting, yeah.
Then another one from Frank Macha. Are the current practices in banking and fintech, such as fraud detection and credit scoring, related to the concept of cognitive digital factory? Of course, it's from the banking industry, I understand.
Yes, actually, artificial intelligence in fraud detections and credit scoring are a commodity. This is common practice now. So every bank is using it, every financial institute is using it, governments are using it. With respect to a cognitive digital factory, the agentic part in fraud detection or in scoring is relatively little, because you analyze data and then you get a result. There is not so much action that can be triggered by an artificial intelligence. So the agentic AI part is relatively low in there. If you give me 20 seconds, I would not now know a reasonable example where you can use it in the big style. But if you're from the banking industry, maybe you could immediately tell me actually how the AI could actually react also and do something. In terms of fraud detection, of course, it can shut down some trading. So if it finds out that there is some illegal trading going on there in the market, it might be shutting down trading of certain things. Of course, such things are definitely already in action in a certain way. I'm not sure if it's done automatically, but semi-automatically for sure, that the AI makes a prescription, says, please stop trading of soya beans for the next 24 hours because there is something bad going on there.
Thank you. So another question from Mr. Jess. Actually, this is related to on understanding whether there is an African database for agricultural research. So, Mr. Axel, maybe from your experience working across different regions in Africa, could you share your perspective on this and maybe to understand how such data ecosystem support the development of cognitive industries?
I'm tempted actually to bounce a question to you, Dennis, but actually I know that the African Union and a couple of the United Nations organizations, they have such databases in a, let's say, in a small scale. But especially for the Africa agriculture research, there exists some of them. I would start looking at the African Union websites, actually, which are the prominent ones. And the UN FAO and Oxfam, they have such databases, from my knowledge.
Yeah, thank you.
But that's not the only ones. That's the one I know. That's not the only ones, but that's the one I would know.
Maybe from my my understanding and my experience, what I can say about this, of course, we don't have exactly a single platform which connects all these kind of things. We have some of the initiatives ongoing, like the CGR data platform. So actually, these kind of initiatives are fragmented. They are really fragmented, and we actually need to do a lot of work in order to make sure that we combine these kind of initiatives and then get to have a one single platform that we can be able to secure all this kind of information. So it is still a challenge, but there are some of the initiatives ongoing. Apart from that CGR, I understand also organizations like the Food and Agriculture Organization and some of the African organizations have different kind of initiatives ongoing. Thank you. So another
one. By the way, if you say the word fragmentic, that brings me to one point. I'm permanently proposing the concept that one of the big places, academic places in Africa, they should take the lead and say, okay, we are going to be the research institute for this and this. When I saw the question came from Jess Modern, and he's from Mauritius. And for Mauritius, I'm suggesting for quite a while that they at least take the lead when it comes to blue economy, to maritime economy, to economy of the ocean. So then they can have the big databases at least related to the ocean. Why are you not doing something in Dar es Salaam simply for East African farming? So that's something a university could take the lead together with the states. And you would be the world center for knowledge, like you have in Svalbard in Norway, close to the North Pole. You have this big database of all plants that are going to extinct. So you find plants that are no longer exist in the world, but they have collected them. something like this, an idea for the academics.
Sure. Then thank you. Another question is from Umbiko Shumba, asking if cognitive AI can be able to do statistical analysis, which is a very important component in research. To my understanding, yes, it can indeed support, and it even goes beyond the traditional methods, not only processing the large data sets, but also it can be able to identify the patterns, but also maybe trying to generate the insights and even learning from new data over time. But that being said, I would like to invite you, Mr. Axel, to elaborate further, especially on how these statistical capabilities can integrate with the cognitive cyber forensic factories in the real world industrial applications.
Yeah, but you said it all actually. The statistical analysis, this is the basic components of machine learning. So that is a, let's say, a prerequisite to have a cognitive factory. If you can't do this, your cognitive factory will never fly. So that's for sure a definite yes.
Thank you. And here we have another one from Professor Zaipuna. He's asking if you can share some insights on ethical issues to be addressed before or as one considers to deploy the the digital factories.
Well, here we have the classical question of the knife. Is a knife a good thing or a bad thing? You can cut meat, it's one of the best tools you can have, but you can also murder people with that. So it's the same with cognitive factories. If you use it properly, if you use it in the sense of the people, it will create more employment, it will create better world, it will create more safety. So it will do a lot of things for you. But if you abuse it, on the terms of ethical issues, it's the same question that we have with AI. We should always have a component when we introduce artificial intelligence. A component means a kind of a board, a kind of a steering committee that reviews if the AI is doing harm. Recently, we had this topic with the United States of America when Anthropic denied the US government to use their AI, in this case Claude, in military operations or in any operations where people could be harmed. This does not mean if they're gangsters, they are still using it, but that is something we can put on the table and say, if we build a cognitive factory, it can be used only for this purposes, and it should do good to the people and not do bad to the people. But the topic itself would be worth a complete session for 1.5 hours, a minimum, just to discuss what kind of ethical actions should be there. So let me keep it brief there. It can be good, it can be bad, and it's up to the humans to do it to the good.
Sure. Thank you very much. And with the regulatory frameworks in Africa, I think we understand that they are still evolving, and we really need to invest a lot in that aspect. So some of the initiatives are ongoing, though we're a bit slow, but maybe one day, yes. Okay, I see we do not have any other question unless if
okay.
They take maybe one more before we close the session. If there is any other one, I would allow one more question.
Anyway, we have our forum now. So those who are not in the forum, I think Mr. Dennis will invite you also to the WhatsApp forum there. And if you have more questions, you can either post them in the forum or you send it privately to me if you think it's a more sensitive one. So you will have my contact details. So
I
there
think we can
anyway.
share let me try to share the link for the group here before we close the session,
Yeah.
so that they can be able to join. But once again, while I'm looking for the link to share, on behalf of Africa Research Institute for AI, I would like to sincerely thank you, Mr. Axel, for sharing
Yes.
this knowledge and insights with us. So it has not only expanded our understanding of cognitive industries, but it has also challenged on how to think about Africa, how we can position ourselves in the next wave of industrial transformation. Of course, as I've already said, we are delaying and too slow on that. I can try to see the situation in Tanzania when it comes to industrial automation. We are still lagging behind, but at least for South Africa, I think they are far much advanced in that aspect. So we need to keep pushing. To all participants, thank you for your time.
Thank you for having me.
Thank you for your engagement, and look forward to having more of these kind of discussions in the future. Thank you so much.
Absolutely. I will share the link to the presentation also in the WhatsApp group. I put it also here into the session once, the one that starts in Focus World 2-3 messages above. So if you want to download the presentation, you can feel free to do so.
Sure. So thank you to everyone, and I think this is the end of our meeting for today. Until next time.
Thank you.
Bye bye.
Bye bye.